Good morning, tenors. Today we are going to start with a new chapter, Moles and Stoichiometry. In class 9, you have studied gas laws, for example, Boyle's law, Charles' law, and gas equations. You are very much familiar with temperature, pressure, volume, and the units in which it is measured. Temperature in Celsius or Kelvin, pressure in atmosphere or centimeter or millimeter, volumes in liter, decimeter cube, centimeter cube, or ml. Today, I'll teach you Lussacs Law of combining volumes. How do I define Lussacs Law of combining volumes? When gases react, they do so in volumes, which bears a simple whole number ratio to one another and to the volumes of the products, if gaseous, provided the temperature and pressure of the reacting gases and the products remain constant. What does that mean? It states that when gases react, that means this law is not applicable to solids or liquids, only to gases. So when gases react, they do so in volumes, which bears a simple whole number ratio to one another and to the products, provided they are measured under similar conditions of temperature and pressure. That means the pressure and temperature should remain constant. Now let us take example of how water molecule is formed. Two volumes of steam are formed when two volumes of hydrogen reacts with one volume of oxygen. So H2, how many volumes? Two volumes. O2, how many volumes? One volume. It gives two volumes of H2O. Then what is the simplest whole number ratio? 2 is to 1 is to 2. That means two volumes of hydrogen reacts with one volume of oxygen to give rise to two volumes of water. Similarly, how is ammonia formed? When nitrogen gas reacts with hydrogen gas under appropriate conditions, it gives ammonia gas. Now let us take a look at the reaction. One volume of nitrogen gas reacts with three volumes of hydrogen gas to give two volumes of ammonia. So what is the simplest whole number ratio between the products, between the reactants and the products? It is 1 is to 3 is to 2. That means if I take a closer look at it, the reactants, how many volumes? 3 plus 1, 4 volumes of reactants are needed to produce 2 volumes of ammonia gas. So, one volume means any particular volume at the given pressure and temperature. Now let us take a quick look at problems based on the law or numericals that are based on Gay-Lussac's law of combining volumes. As I told you, this law is applicable only to gases and not to liquids or solids. The first question: 450 centimeter cube of carbon monoxide and 200 centimeter cube of oxygen are mixed together and ignited. Calculate the composition of the resulting mixture. So, how do I solve this numerical based on Gay-Lussac's law? In this question, they have not given you the balanced equation. So first step, I'm going to write the balanced chemical equation. So what is the required equation? 2CO plus O2 gives you 2CO2. Now look at the reaction. Two volumes of CO, that is carbon monoxide, reacts with one volume of oxygen to give you two volumes of carbon dioxide. Now, to calculate the amount of unused carbon monoxide, how do I do? Now, by looking at the proportion of the volumes, okay, the ratio of the volumes, I know that two volumes of carbon monoxide utilizes one volume of oxygen. Therefore, what volume of carbon monoxide will use 200 centimeter cube of oxygen? Okay, because in the question they have given you 200 centimeter cube. So by applying simple unitary method, x is equal to 400 centimeter cube. Now you have calculated the volume of oxygen that is consumed and not the volume of the unused oxygen. Therefore, the amount of unused, that means excess carbon monoxide gas, is equal to, initially you were given 450 centimeter cube and you are using only 400, that means minus 400 equals to 50 centimeter cube. So this is the volume of unused carbon monoxide. Now, how do I calculate the volume of carbon dioxide formed? By looking at the equation, you know that two volumes of carbon monoxide gives you two volumes of carbon dioxide. Okay, now you know the volume of carbon monoxide that is being utilized. Okay, find the volume of carbon dioxide that is formed. So the amount of carbon dioxide formed equals to 400 centimeter cube. Is very simple mathematics, is simple elementary method. Total mixture, how will you find out? Look at the 400 centimeter cube plus here it is 50 centimeter cube, that is 450. So your answer is CO2 formed is 400 centimeter cube and the volume of unused carbon monoxide is 50 centimeter cube. You got to practice the numericals once, twice, thrice and read the questions very carefully. Now let us take a quick look at question number 2. One volume of nitrogen combines with one volume of oxygen to form two volumes of nitric oxide. Calculate the amount of each reactant required to produce 250 milliliter of nitric oxide. So first thing, I'm going to write the balanced equation. So N2 is nitrogen gas. It reacts with O2 oxygen to form nitric oxide. The formula is NO. So the balanced equation is N2 plus O2 gives you 2NO. That is, look at the volume. One volume of nitrogen reacts with one volume of oxygen to give you two volumes. Whose law is that? Lussacs Law of combining volumes. You are supposed to calculate the volume of nitrogen gas required. So NO is to N2. That means 2 volume is to 1 volume. If the volume is measured in ml, so I'll take 2 ml is to 1 ml. Therefore 250 is to x. Find the value of x, that is 120 ml of nitrogen gas is required. And then to determine the amount of O2 required, NO is to O2, that is 2 is to 1, means the volume is 2 is to 1. Therefore 250 is to x. That find the value of x, it is how much? 120 ml. So amount of oxygen required is 125 ml. Now look at question number 3. What volume of oxygen would be required to burn completely 400 ml of acetylene? Acetylene is H2. Also calculate the volume of carbon dioxide formed. It is same as the ones that we have discussed, 1 and 2. And here also you have to write the balanced equation. How do you write? Oxidation or burning of any hydrocarbon in excess of air gives you carbon dioxide, water vapor, and heat energy. So I write the equation 2C2H2 plus 5O2 gives you 4CO2 plus 2H2O. Now, according to Gay-Lussac's law, what is the ratio? 2 is to 5 is to 4 is to 2. Now, what you're supposed to calculate? You're supposed to calculate the volume of oxygen required. So by simple unitary method, you calculate the volume of oxygen required, and then you're going to calculate the volume of carbon dioxide required. Thank you.